So we're going to look at this graph f of x equals x squared plus 1, and we're going to see what effect that has when we do this g of x transformation on it. And we're going to look at this g of x now. So g of x equals negative f of x plus 2. And we know that f of x equals x squared plus 1. And that would be negative times the x squared plus 1 plus 2. Let's multiply the negative through, and we get negative x squared minus 1 plus 2. So g of x is eventually going to equal negative x squared plus 1. Okay, so up here we can write that g of x equals negative x squared plus 1. And we'll come back to that later on. But what we want to do is concentrate on this f of x. Well, we know it goes through certain points on the graph. Let's just have a look. So for here, if x is 0, we know we get 1. If x is 1, we know we get 1 squared plus 1 is 2. And if x is 2, we get 5. So 2, 5. And of course the negatives go the other way. So if x is negative 1, we get 2. And if x is negative 2, we get 5 again. So we get this parabola formed. We know it goes through 0, 1, which is about there. Not very easy. 1, 2 is about there, and 2, 5 is up there, and then negative 2, 5, and negative 1, 2. So this parabola comes down and up like that. Now, if we move over to this bit here, the negative f of x is a reflection. Can't quite write, it's too small, but c'est la vie, in the x-axis. So reflection x-axis. Handwriting's terrible, which means that this graph, the red one, gets reflected downwards and will go like that through the point, which is not very good at all, but try it again. And it goes through the point. Again, still not very good, but you got the idea. It's been reflected down. Then we move on to the plus 2, and that's 2 units up. So this graph, the blue graph, gets shifted 2 units up, and it will go through that point there and come down. And that will be the graph of, as we predicted at the beginning, negative x squared plus 1. So how can we prove it? Well, we've got a point. So we're going to take any of these points on xy. Let's take the point 2, 5. So that will be the point we choose up here on f of x, top right. 2, 5 we'll choose. So 2, 5, after a reflection in the x-axis here, that means that the the y value gets multiplied by negative 1, and it becomes 2, negative 5. Well, 2, negative 5 is down here, and it's on the graph. And then we get shifted plus 2. So if you take the y value and shift it up plus 2, we get the point 2, negative 3. And that point will be 2, negative 3 is there, that point there. And that's the final graph. But does that point lie on this line here? That is the crux of this. If that point lies on that, then we've got it right. So if x is 2, does y equal negative 3? And of course, g of 2 equals negative, bracket, 2 squared plus 1. And negative 2 squared is negative 4 plus 1, negative 3. And the point indeed is the point 2, comma, negative 3.